Now that you've learned how to manage the file system in Ubuntu Linux Server, let's move on to talking about RAID. In this first video, we will briefly introduce you to the concept of RAID, what it is, how it operates, and why in a real-world setting you would want to employ it. In the following video, I'll walk you specifically through the process of creating a RAID 1 array on Ubuntu Server. And in the final video in this segment series, we'll show you how to remove a RAID array from your system. Let's get started talking about what RAID is. RAID stands for Redundant Array of Inexpensive Disks, or it's sometimes called a Redundant Array of Independent Disks. Now, what you're doing with RAID is you're linking hard drives together in such a way that they can do things that one single hard drive by itself would not be able to do. There are different levels of RAID. In fact, there's RAID 0, RAID 1, RAID 2, 3, 4, 5, 6, and RAID 10, or it's commonly called RAID 10, better described as RAID 1 plus 0. We won't be discussing all of those different levels. As a matter of fact, some of the differences between the levels are quite minute. But in this video, we'll be talking about the most common RAID levels, which is RAID 0 and RAID 1, and then a combination of those two levels, which is RAID 1 plus 0, commonly called RAID 10. Now, RAID 0 is going to form a striped volume. If you remember when we installed Ubuntu Server, there was a question about setting up LVM, the Logical Volume Manager. Well, RAID 0 is going to act a lot like the Logical Volume Manager. It's going to allow you to take two or more disks and stripe your data across them. Now, what this means is that neither one of those hard drives in the array, or however many you have, none of those disks in the array actually contain your data by themselves. The data is literally striped across the disks. So if you have, let's say, for example, two 1 terabyte hard drives, you could put them together in RAID 0 and they would appear as one 2 terabyte striped volume, or one 2 terabyte array. And so if you had a file stored on that array, pieces of that file would be striped across the two disks. So you would say, does my file reside on this 1 terabyte drive or this 1 terabyte drive? And the answer would be parts of it exist more than likely on both. Now, why would you want to do this? Why would you want to stripe your data across multiple disks? Well, it's all about performance, and I should say as well that some people don't consider RAID 0 a true RAID level because there is no redundancy with RAID 0. You're simply putting disks together for performance sake. Basically, by having your data on two disks, you have two workers, where if you just had one hard drive, you'd only have one worker, one drive, that could find your data. Hard drives move in a linear fashion, finding the data that's on them. And so if you just have one hard drive, it has to move from one bit or one byte or one file to the next in a linear fashion. Okay? If you have two disks in a RAID 0 array, they can be bringing up the same file, they can be bringing up the same data, but much more quickly because you have two workers. You don't have to wait to find the first byte. The second disk can already be moving on to the second, and so on and so forth. Now, if you'd like a good example of this, imagine that you ask one person to go get you two separate files in two separate file cabinets. So, of course, they're just one person, right? They have to go to the first file cabinet, pull the file that you need, then walk over to the second file cabinet and pull that second file that you need, and then come back to you with your files. Now, let's say that whole process takes 10 minutes. Okay, the filing cabinets are really far away, let's just say. Imagine if you had two people and you assigned the first one to go get one file and the second one to go get the other file from the other filing cabinet. Well, theoretically, you'd be done in less time than 10 minutes. I can't say that it would be exactly cut in half to 5 minutes, but because you would have two people working on pulling up these two files at the same time, you would get your files faster. Now let's move on to talking about RAID 1, which we'll be covering in depth in our next video. RAID 1 is going to be used to essentially create a mirror. If we use the same example here, the same scenario, with two 1 terabyte hard drives, we would link them together in a RAID 1 array to form one 1 terabyte RAID 1 array. Now, why in RAID 0 did our two 1 terabyte hard drives become a 2 terabyte array, and in RAID 1, our two 1 terabyte hard drives simply became a 1 terabyte array? It's because of the way that RAID 1 works. It's going to be a mirror, so that whatever you do to this first 1 terabyte hard drive will also be done to the second. It's for redundancy, so that whatever you do to this one will also be done to the other one. Now, why is RAID 1 used? Well, unlike RAID 0, RAID 1 is not used for performance sake because essentially the array is going to perform the same as a single hard drive. Instead, RAID 1 is used for redundancy. And what that means is basically it protects you from hardware failure. Suppose that a hard drive fails. You would lose the data on that drive unless, of course, you have backups. But even in that case, you would have to pull the data from the backups, and that backup may not be the most current information. Now, it's important to understand that redundancy and backups are not the same thing. They should both be a part of any good backup plan. But if you had two 1 terabyte hard drives in one single RAID 1 array, and one of those hard drives failed, you wouldn't lose any of your data because the other hard drive would contain all of the data, all of the information, and you wouldn't have to pull from your backups either because that disk would have everything current on it. What you would simply do is go into your machine, use MDADM to mark the failed disk as failed, then you would power off the server, pull out the physical disk that failed, put in a new disk, restart your server, and then you could tell the array using MDADM that you had installed a new disk, and that new disk would sync up with the other disk so that your data would not be lost at all. Now finally, RAID 10 or RAID 1 plus 0 is simply going to be a marriage between RAID 0 and RAID 1. You'll get the performance boost of RAID 0 and the redundancy of RAID 1. It is important that you understand that RAID can be hardware or software based. In our case, we will be using MDADM, a software program, to form a software-based RAID 1 array. Also, you should, in a real-world setting where you have important data, be using identical disks, both in size as well as manufacturer and model, if at all possible, because slight differences between disks, including the number of heads and cylinders and things like that, can create problems. So it's always good to go with the same manufacturer, the same model, and the same size when you're forming a RAID 1 array. I think that's about enough theory. Hopefully you have a decent understanding of what RAID is. Let's move on now to creating a RAID 1 array using MDADM.